Afternoon, everybody. It's a great pleasure for me to be here and to be able to share 2 hours with you on a topic which lies close to my heart, which has followed me all my professional life until now. And I'm very glad that I may share a few of my thoughts and experiences with you. We collectively overuse the environment. I think we would agree on that. The fact that we meet here is proof of that, otherwise we wouldn't meet under the heading of oikos, would we? Being a trained economist myself, I would expect external effects to be internalized. But I doubt it will happen on a sufficient scale within acceptable time. We have to ensure that it does increasingly, but and so on. And at the same time, we collectively take millions of decisions every day, altogether millions. And quite a number of them have direct or indirect effects on environmental issues. Whether I buy a cotton shirt or well, whatever kind of plastic shirt, we have upstream processes which to a varying degree influence the environment. If I take the bike or the subway, if I buy a diesel car or electric car today, and we have upstream all the questions with batteries, producing of batteries, lifetime of batteries, replacement, waste treatment of batteries. And let me come to I'll jump a bit. With diesel, we had about 4 or 5, maybe even more, maybe 10 years ago, the European Union decided to set a goal of 10% biodiesel to be put in the diesel supply chain. Am I understandable? And then there was an interesting analysis of the various fuel chains. And I'll jump to a result table, and over time of these following minutes, I will go into the details of how this came about. That's the central result table of a study done at the Swiss IMPA, which is a part of ETH, which you may have heard about. And what it shows is the analysis, well, it's the quantified and weighted environmental impacts of various fuels. Those are the fossil fuels. This is environmental impact in a unit which is called impact points. I'll show you more on that afterwards. And the red line I took on diesel. Diesel and gasoline being very close, you can't see the difference here. Natural gas being slightly better, meaning less impact. And up there you see a variety of biodiesel. How do you say in English? Bio? Biodiesel. And what you can see is that some are better, some are worse, some are even extremely worse, according to this method. And now we could look for biodiesels which you might know. Mexican or American corn, which in German is mais. This is soy, rapeseed. That's a very famous one, rapeseed. That's the most often used. This is American corn. So on first side, what it tells us, from an environmental point of view, don't mix it in. The impact is larger. Here you have a more straightforward assessment. This is only climate change effects. And here you see, compared to diesel, gasoline has slightly more. Most of the biodiesels fare better. Where is the US corn? Where did I have it?
Ethanol, nice.
Ethanol. It's the same. It wouldn't help. It wouldn't disturb, but it wouldn't help. Certainly not worth subsidies.
Does that figure include transportation calculations? Or is
Okay,
it
now
just-
what does it include? Of course, now we go, very good question, thank you. First of all, what is the unit it is calculated for? It's calculated for 1 person kilometer. So it includes everything you need to transport a person in a defined car. It's always the same type of car for 1 kilometer. So it includes a average consumption, a lifetime of a car, because the car is produced. It includes the infrastructure. It might even include the infrastructure of the road, I'm not sure, but that wouldn't change. But what you see, infrastructure is the first part. This is infrastructure, which is always the same. And then we have, in the case of biodiesels, the dark green is agricultural production. No, agriculture. Then the second one is production of the fuel, which in the case of corn is a factory, which in the case of here is a refinery. Then come all the transports which are needed to do so. Here you can't see them. They are included, but you can't see them. Here is more. And then the actual emission from running the car, which is the dark gray. And with this, I can jump to some basics on how to do such an assessment.
It's in German. Can you put it in slideshow?
Say it again?
Slideshow.
Normal. Oh, it's not. I'm sorry. Now that we're on the wrong one. Just a second. Thank you. Very good. Yes. Now the study was done by EMPA in Switzerland. I'm not sure if it's translated into English, so this is German. Which of course is a problem in academia, that the information flow from English to works better than from something to English. This is slightly larger, with just some text parts. So, I'll jump to the elements of how to do such an assessment. That's pretty relevant for the whole thing. And then I might show you a few more examples. And just a second, let me look for it. Where is that? Here. Such an assessment is done in 4 steps. First one is to find what do we look at. Here we wanted to compare different fuels. Other instances, you would have a company wanting to analyze its product, just to see where are hotspots. We did that, for example, for the Swiss National Bank, doing the LCA on the banknote, just to see where are environmental hotspots. You will look at things differently if you compare than if you just analyze one process flow. In that case, it was a comparative analysis, which on the market, of course, is relevant. Some people would want to gain from such results financially. Some people might lose from that. That's why it's a bit more sensitive. Why don't? I don't know why. Second element is then getting the data for the processes that you want to analyze. That's a lot of data crunching. Today it's done with databases which contain data for maybe 10,000, 15,000 processes. Wood needs to be cut in the forest, needs to be transported. Then for that you might have standard transports. Maybe not. In the case of coal, you don't have standard transports, you have these huge trucks in the mines, or for copper. Then you have to treat the wood, and so on. A few thousand processes are analyzed, and you have some data in a database. Lots of processes are not analyzed. You don't have data. And that's where data crunching becomes even more difficult when you want to analyze something. Then you would get a result. I'll show you what a result can look like. Yes. Now let me first show you a structural. We have lots of information on emissions, but then we are faced with the problem that these emissions impact on varying environmental topics. On the consumption side, if we compare, for example, vegetarian, vegan, fish-based or meat consumption, that would be a topic which somehow should be included. Overfishing, for example, where we have an unsustainable use of living resource. And then, of course, these we understand. And with a variety of emissions, with a variety of effects. Physical destruction of a biotope. You don't extract something, you just destroy something. And then not so clearly attributable or physically catchable emissions, like the light effects, noise, vibrations. Now, today's methodologies for assessment. Oh, first of all, lots of people, due to that complexity, refer to one impact, which is climate change. You will see a lot of climate change analyses these days. Lots of companies give a climate report, products being compared on climate grounds, and it's an important issue, of course, but not the only one. And it's hard to say which is the most pressing one. A Danish scientist, quite a provocative guy, Mr. Roll, he presented this, trying to say of the various environmental topics, in which are we still within the green line and within which not. And then where is climate change? His study group said, yes, it's relevant, we overshoot, but it's not the one that strikes us most, if we look at the graph. Biodiversity loss. Now, biodiversity loss from our point of view here is tricky because that's not something we do except with overfishing or similar things. No, we don't go and kill too many animals just for whatever purpose. Safari is not the major problem for biodiversity, where we directly kill animals. So this happens because we change land surface for streets, for agriculture, for construction. It happens because of emissions into water, which may, for example, our sunscreen has hormonal effects, which hinders fish procreation. So we have a number of pathways which lead into that, while this is quite a direct pathway. We emit something and we change the radiative forcing. Here also we emit nitrogen in bioavailable form. So his analysis is not directly usable in our situation, but it gives an indication on what to look out. And it's an indication that climate change is important, but not the only topic. Because not in many cases this is linked to biodiversity, and in many cases it's not linked to nitrogen. As soon as you have a catalytic converter with a car, nitrogen effects are lowered, climate change effects are not lowered. So, over time, the question of how to how to assess, how to evaluate various impacts has created lots of questions. I'll show you another graph which gives a often to be found result structure. Sorry. If you ever can lay your hand on a product life cycle assessment, very often you will find result graphs which look like this, where climate change is analyzed. All the contributions here, it would be two compared alternatives. The worst one being set at 100%, whatever amount of climate change, tons of CO2 per any unit will be, and the other one less. And you see, for example, in climate change, this case version blue is better, ozone depletion version red is better, human toxicity, cancer effects, blue is slightly better, non-cancer human toxicity effects, blue. Here, the red one's better on ionizing radiation, and the red one is better on mineral and fossil resource depletion. So this is a often to be seen result format, where similar to what Rockström did, but closer to the data that we have, coming from the process point of view, we have a machine running and it emits and it consumes, and we take it down and we multiply it, we get to such results. And this is very interesting and not helpful. In many cases it's not helpful, because I would not know which product to choose if I would be in the position that I have to choose a product. If I'm in the position that I have to adapt a process, then I can use this. Maybe. Maybe. So, already back in 1980s, a teacher of mine at university, a professor, developed the first approach to assess these quantitatively, with the aim in mind, as we have dollars or Swiss francs or whatever for economic terms, to have a point value for environmental impacts. That was the goal. And Rudi Müller-Wenck, he did the first publication on that. I followed in his footpaths and did a second version, which we, together with a major retail chain in Switzerland, Migros. And they were fed up. There was a guy there responsible for packaging and environment, and he was fed up with all the wonderful, shiny, glossy papers of all industries telling him why their products would be environmentally superior to others, each of them focusing on the one which happens to be their best shot and forgetting about the other aspects. And he just wanted to have a neutral analysis of all, as much as possible as all, certainly not dependent on the suppliers, and certainly not dependent on him, because he said, I choose packaging, I buy packaging, but I'm not the environmental specialist. That should be somebody else's job. And so we developed an approach which I will show you, and it shows results in a very simple way. Once the big work is done, it's very simple. For example, as you have seen here. That's relatively simple to look at. The method behind, of course, let's discuss that. Today there are two approaches to do such, it's called weighing or weighting. Weighting. One is based on legal limits, environmental policy goals, and one is based on damage. What damage is created? And I will introduce you a little bit into both. More detail on the legally based one, that's the one I further developed. To use it afterwards it's the same, the foundations are different. I start with the damage one. We start not to be seen with a a bundle of processes, like the construction of a car, the running of a car, and if the car runs 100,000 miles, no, that's maybe too much, well, maybe not, then you have 160,000th car plus 1 mile. The production of a car divided by 160,000 plus 1 mile, which needs so and so much amount of gasoline, and so on. So you have processes, and altogether they have resource consumptions and emissions. All kinds of. And it's really all kinds of. Because to produce a car, you have the whole steel industry. And to produce steel, you have the whole coal industry. And then coal miners, workers, they smoke. So you have the whole tobacco industry. No, usually forget that. Anyway, these process chains get huge. That's why the databases are necessary. And then you have these 2,500 types of resource consumptions and emissions which are embedded in these databases. And let's just take one. The chlorofluorocarbons, the dashes are not precise, they're just symbolic, because that certainly doesn't induce land transformation, but it goes to climate change, some of them, most of them, and of course to ozone depletion. So it will have two effects. Next question, what does climate change do? Well, climate change changes physically the climate forcing. Well, damage. Well, what's the damage? You get into quite interesting questions, and you can do that for all. What happens with ozone depletion? Ozone depletion also says damage. The methodology, of course, is more detailed. It's absolutely fascinating going through this. It's a bit time-consuming, but you can also browse through that documentation. The latest one just was published a few months ago, Recipe 2017. Structure is the same. And it really takes together what we know of what are actually damages coming off such emissions and impacts. Now, in the case of climate change, the damages are asked for specific areas of concern. It's called safeguard subjects in the language of LCA. And the areas of concern of a safeguard subject are human health, ecosystem health, and resource availability. Here, the common denominator is a World Health Organization unit, DALI, disability adjusted life years. Starting from Japanese females, which have the highest life expectancy, around 85. You could deduct that where people die earlier, something happened. Now, to what extent do our activities influence such earlier deaths? And if somebody dies at 83, then he has lost 1 year. If you get sick, you're not dead. But the World Health Organization has developed a scale which tells you if you have that sickness, that compares to 10% death. It's not 10% death, but it's considered to be a tenth of value or of damage. And they would have asked doctors, just to give an assessment, what they think. A skin rash is very little. And you can imagine, it's an interest, in itself, it's an interesting field of thinking. But what it allows to do is to say, if we have ozone depletion and decreased ozone concentration, we will have skin cancer problems and eye problems, blindness and cancer. Cancer leads to sickness periods and premature death, and blindness is somewhere on the DALI scale. And by linking the statistics to the emissions, it's possible to get at some effect. Ecosystem health looks for species and species loss in areas. That's even more complicated. And then resources is, I think, methodologically the most complicated, because there is no healthy state. But you create a today state and a deterioration by reduced concentration of minerals or other. With water, it doesn't work yet. So, scientific good approach, I like it. I mean, from the concept of science. Not all areas of concern are covered. You just see some, actually some of them link again to ecosystems. Area change leads to ecosystems. And then we have the last step. If we want the point system, we have to weigh these against each other. We did some Delphi studies in Switzerland and in the Netherlands to weigh the effects, subjective, of people who have an understanding of the topics. And it yields a point result, a point methodology. The second, which we use in Switzerland, which is quite widely used in Switzerland, has another approach. It's less obvious to see here, so first a few words. The idea is to ask for environmental impacts. What is today's state and what is an acceptable state? An acceptable state of pollution or of consumption. Now, who defines what is acceptable? Well, in many cases in Switzerland, we are lucky to have an Office of Environmental Affairs who has scientific commissions supporting it, and they give indications of what is an acceptable level of pollution or a minimum level of quality. Maximum pollution, minimum quality. It's not the same as having exhaust limits. If you have 80 milligram of NOx in the exhaust of this chimney, you don't have a clue of what the ambient air quality level should be. So it's not the same. Emission levels are asked for here, not emission levels. But also in the US, you have for certain pollution gases, you have emission levels. From that, you may, based on models, calculate, well, how much emission is possible not to exceed those emission levels. But that needs some science too, which I can't deliver. I just can ask the questions pertinently until I have answers which we can use. And in the case of NOx in Switzerland, we have a figure which is embedded in a clear air, not act as you have, but in a clear air plan. And we have annual statistics. And by applying a relatively simple formula, it has two, afterwards I'll show you, it has, may have three variables. We can calculate a point. Now let me go back slightly in history, because that's the current format, and I'll come to that. I'll come back to that. We started out with a very simple formula, and we said we want to have two values. The first one, the current flow now, which would be the 70-something thousand tons in Switzerland, and a maximum tolerable flow, which were now the 45. And then we can build calculate a relation. 79 over 45 is 1 point something. But that alone is not enough. That would be the second. The actual flow over the maximum acceptable, that's 1.6 in that case of NOx in Switzerland, 2012. But that in itself is not enough, because we may have CFCs where we have a few tons. We may even have dioxins where we have a few grams per year, which may also stand at 1.6 actual over maximum acceptable. But everybody would agree that a gram of dioxin is not equivalent to a gram of NOx. Pretty much not so. So we need a second element to consider for absolute size, which is in the first one. How much of the cake, of the acceptable cake, is my gram or my ton, which is the first one. If I emit a ton, it gets 1 point over maximum flow, which here would be 45,000 tons. In the case of dioxins, a few grams. times the use or overuse factor. The formula is still the same, but it's formulated slightly different, which allows for a differentiation. In global LCA work, this approach is looked at quite critically. You would much easier find critiques of this weighting step compared to supporters. And the average colleague of mine would have his data and then have the question of how to assess it, and what also the ISO standard 14040 is on product life cycle assessment. And what the ISO standard concedes to do is to normalize. It says, well, you can put your values compared to the total emissions in an area, which we have here. But it's not under the line, it's above. So they would say, yes, you can use your emissions divided by actual flow. That gives a normalization. How much is my compared to everybody's? Am I a big player? Am I a small player? And you can ask that, am I a big or small player in climate change, in ozone? Gives you an indication. So we changed the formula. A colleague of mine did that step, and he said, okay, we start by putting this first, and he actually just entered F, let me think. Now I have a, Weizsäcker, an hang-on. No, well, let me just think. It's not all black, it's gray. He I'm really a blackout. I'll quickly look it up. What do I have it here? Small. Small F. It's just one element, and I didn't take it down. So stupid of me. Maybe actually you find it out, because it's the difference is just, you could also put here F actual. It's a little change, because this is also a current flow. I want to come from that to 1 over F, so I add F max over F. F. Actually, what he did is he just entered F actual over F actual and then exchanged those.
Didn't he add F actual over Fn?
Well, Fn is a second addition, okay, because Fn and F actual is both a current flow. So for the first step, take it as equivalent.
Okay.
So what he did was he entered just F actual over F actual. And then, as these are multiplications, he exchanged here and put the F here and took the F max over there, which made F actual over F max, which together gets this, and you stay with F current. F current over F current over F current. F current over actual over F actual, and then you exchange those two. You can put those two together, and you stay with F current here. And then he says, well, now we have a differentiation possibility. And he says, sometimes current flow happens in various areas. But that's the next step. First, I want to make sure that my blunder didn't impact too much on you. Whether you could still follow what I was trying to say. The aim was, we thought this is a useful, simple, very simple. That was an aim, to have it simple, and to have understandable elements. There is enough complexity in defining those, especially the threshold value, which is a story for each and every element we look at. all the, for example, all the categories you've seen before. So the calculation doesn't need to be complicated. We don't even know enough to make it complicated. But we wanted to have here this traditional way of looking at that we first ask what's my share of the actual flow. And in order to get to that, think for a moment as these being equivalent. Then, because it's current flow and current flow, just a differentiation earlier. We wanted to have this element here, and you can mathematically get to it if you add F actual over F actual and then exchange these. As in a multiplication, you can simply do that. And then you end up with 1 over F actual, and then you have these in square. Now, we get a point value. I would, for the time being, if you wouldn't ask questions, leave aside this differentiation. Or I can give you a hint. For the reason why we introduced it, it was water use. We have areas in the world where there's water shortage, and areas where there's not. In Switzerland, certainly there's no water shortage. But we import products from everywhere, and the databases just show water consumption. And water consumption in Kazakhstan for cotton production is in an area where there's water shortage. Lake Aral shows us. So to have a ecofactor for water consumption based on Swiss water consumption limits doesn't make sense for water consumption in Kazakhstan. So he said if we exchange these and do as such, we do have a current flow and the current flow here. But he says in this way of looking at, we can geographically separate this and this. So that remains in Switzerland, or for the calculation. But here we can exchange the values depending on where the water consumption takes place. And this is a simple factor, right? In the case before it was 1.7 to square. And in the case of Swiss water, it would even be 0 point something because no water shortage. And in Kazakhstan, it would be maybe a value of 5 or 10, which to the square then becomes 25 or 100. So that makes a difference. And that's why he introduced that differentiation, which up there is not that easily possible. Okay, so simple formula, and I managed to make even this simple formula complicated enough. I'm sorry. And I would like to show you why this is important, and then do a little assessment on pros and cons, and have some discussion.
The formula compares 2 countries, or can it compare or more than 2?
The formula basically does not compare. The formula gives how to calculate a, what we call ecofactor, the ecological weight for a certain kind of environmental impact. As the example before showed here, this is all done for Switzerland, so N and actual doesn't change. We have 45,000 tons limit. We are still higher, not quite the double. And if you enter the values, you will get to this. And the 10 to 12 is just not to get two small numbers. It doesn't have a meaning. So it creates a systematic calculation approach, and we can do this then for all kinds of resource consumption and emissions. NOx we just have seen. And here you have the differentiation of the normalization value and the current flow, N and actual. And in the case of NOx, it's the same. In the case of ammonium, it's the same. In the case of VOC, and so all of these are the same. I would have to look up, as I told you, water consumption, for example. We have different values for areas of the world with different water shortages. So here you see a difference. I won't go into detail. It's a shortcut, because with particulate matter, the data is not good enough. So he had to construct something.
Is this part of this calculation is able to catch outliers that are too minuscule to have in any other equation?
Can you repeat the question maybe with other words? I'm not sure if I understood you.
Because like the smaller numbers where you're doing like 10 to the 12th power to make sure that you can calculate them, that say some of the trace contaminants or the types of pollution that this model is, where usually those data points would be outliers.
Ah,
That those are now being able to
Okay.
be captured in this data set.
okay. No, I don't think so, because I think the situation is slightly different. We will, individual data points will not show up on that level, because we have two streams of data leading into that calculation, and outliers would be treated with much earlier. For example, lead, emissions into air. First of all, the air section of our Office of the Environment decided, yes, heavy metals, emissions into air are a topic to be included in the table. That's a decision to be taken. Then, they were able to say that because they had data. And you need data on actual emissions, on explaining, well, what's the trouble and where would be a limit, right? Now, in this situation, you see, interestingly enough, they're all on this, no, actually that's the same. Okay, we have some data here. So apparently the emissions in Switzerland are 23 tons of lead to air per year, and the threshold is defined at 32 tons. How do they get at a threshold? There is no legal overall emission limit. That doesn't exist. What we have in Switzerland is a limit for contamination in Earth. Now, nobody expected that that limit would be reached in all of Switzerland's productive Earth. So it's a precautionary limit. So with the support of the guys in the environmental office, a simple model was constructed comparing today's values and the threshold values. And I assume, we would have to look it up how it was calculated, but I assume that they would assume our emission structure, and apparently the values that they measure in Earth, when they take samples, we have regular measuring programs, and apparently there is some room left. And on that level, you would have outliers, extreme data. And then the guys doing that job would have to decide, well, what is the relevance of one extreme value? If you have a local polluter right next to that agricultural area, it might not be necessary that the whole of Switzerland reduces all of its emissions. You might want to tackle that single emittent. So that's where your concern would come up. But once you have the annual values, you wouldn't have such data anymore. Did that answer your question?
It did. It did. I didn't realize that these were annual
Yep.
values. I was
Yep.
looking at
Yep. Yep.
like a specific study
Yep.
more than.
Yep. No, it all
collection of data.
behind each and every, especially the critical flows, there are model assumptions how to get to a acceptable annual flow. And there are more a less obvious one, like energy consumption. Energy consumption is considered to be an environmental topic. I'm not so sure that it is personally. Energy consumption by itself, I'm not so sure where is the environmental problem in consuming energy. I understand the problem of all the waste we create with it. But the fact that we use exergy, okay, but that's a personal position of mine, and I'm in a minority in that field. So energy is in the table. I wouldn't have put it in, but and there we have a political consensus, as we have even popular votes on such topics from time to time, that the energy consumption should actually not increase. But And then we have political definitions of what should be the share of renewables, or especially the share of non-renewables. Now, this leads to my assessment of, the discussion of this. Because this step of weighting, no, sorry, one step too fast. And then we end up with these values. The 39 per gram you have seen before, but all the others, which you can see on the left, also get a value. Now, if I have a process which includes washing dishes, which we will only do with our cups, no, you might wash your... And some of your colleagues took a plastic one, which he or she throws away. So in your case, you will use detergents, and they might contain phosphorus. Phosphorus is not on that list. Maybe phosphorus is on that. No. Phosphorus has an eco factor of about 1,500 to 2,000 points per gram emitted into water. The phosphorus that you use in your kitchen is not going one-to-one into the river. Probably it's being treated. A few percent of that really enters the water. So that phosphorus emission will get weighed with the factor. While for the plastics, well, it had to be produced. Your detergent also had to be produced. Your glass container had to be produced, and after 120 times it will break. We don't know. So, okay, mixed all together, we could have one figure for both, either or. And that's the point, that you have one figure for both. Not 10 figures, as you have seen in the chart I showed you sometime in between. Not such a result, which is interesting but not helpful to decide what to take, but such a result as shown in the very beginning, which pretends, to say this is 10 times more. To use ethanol from rye produced in Europe is 10 times worse than using fossil diesel directly. Rye being the most extreme case. Probably it will also be too expensive because you need processes which create all that pollution. Now, just the pro and cons of this weighting step. First of all, to the top left, this is really dear to my heart. Everybody says, and there are lots of my colleagues who say you can't apply such weighting methods. I say you err, because everybody does. Because whoever takes a decision, implicitly or explicitly, has weighed or weighted, what's the English term?
In this case, it's weighted.
These environmental impacts. Either with a factor of 0, if he or she says, I don't care, this is cheaper, I take the cheaper one. Or by assessing somehow and having it somehow included. And the somehow, I think, is important because people then don't really know what they did. But they somehow you always do it. If only with a weighting factor of 0. Second, such methods have the potential to be transparent. At least if you people can read. It takes some time to realize that transparency, but at least it's possible. And then the third thing is I think is extremely relevant. It's independent. It's independent of the people who apply it. It's independent of the people who pay for the study. It's independent. And it allows for overview. I might show you some more examples afterwards. And it includes all the trade-off questions which very often happen. On the downside, this mix of scientific and political criteria, think of the energy consumption example I just gave you. This is unsettling for people, and lots of people who do such analyses come from the engineering side, and there you don't like political aspects. You wouldn't want to construct a bridge and measuring its stability based on political aspects. We know in enough countries where this is done, because this this person pays me more, so I calculate for his concrete and not for theirs, even though this one doesn't contain enough cement. So we know that this is dangerous. But this is a different situation, because weighting of environmental impacts is no science pure. I give you an example I like. We have phosphorus limitations in Switzerland on a number of, for example, detergents. They're even banned. Phosphorus is banned. Why? Phosphorus is the limiting factor in our lakes, as nitrogen is in sea. What happens if we emit too much phosphorus? Algae, they decompose, they consume up the air, fish die, okay, that passes. And then we create new moors. It just takes 20,000 years until the lake has turned into a moor. But moors are protected. We love moors. Why shouldn't we pour phosphorus in lakes? Well, we don't want it, because it stinks, because we cannot fish, because we want fish. And if we say we want, that's not a scientific expression of things. That's a political expression of things. We want lakes which don't stink for 20,000 years. So the assessment is not per se scientific. So I say, yes, it's a scientific and political mix. And it shouldn't be unsettling. We should just have somehow grounds, not stable grounds, grounds to use. But it is, for many people, it's a critical point. That's why I put it there. Second, independent weighting, a method which just comes in and says, give me your process data, I tell you what's the environmental profile. That's unsettling for industry guys. They would rather have the freedom of choosing themselves. That's why ISO is so hesitant, and ISO says you may not use such a method which I just presented to you for a comparative public study, which I think is understandable in the American context, where such a thing would be used widely, and you cannot control what people did. Not the weighting method. The weighting method is okay, but what did they calculate? And I remember very well that E.T. movie ad, when E.T., well, you know the movie E.T.? So in that ad, he's taken, he takes off, and then he stops over a little nothing place in the wood, and then you have two soft drink containers, Coke and Pepsi, and then he takes one each. It takes a second, and he takes one, and off he zooms. And that was an ad for Pepsi. So, in the US style of advertisement, LCA results would be used recklessly. Understand that. And that's where the ISO hesitation comes from. Third point. In natural science, I had this discussion with my professor. I teach at ETH, and I had this discussion with my professor. She doesn't like the weighting methods either, because for natural science it's not necessary. Because in natural science you rarely prepare economic decision making while you stay in university in Switzerland. As soon as you go out, of course, but for research it's not necessary. For research, the analysis of a profile with many results is okay. And then a critical point which I understand, some people tend to overestimate the correctness of a result because it's not science. I understand. And now specifically for the one I explained shortly and longer, here a strong positive point, I think it has its grounding in environmental policy, which in many cases, here it would be, yes, unfortunately, but here it's also democratically legitimized. It allows for the precautionary principle, because in the damage side, in many cases, we don't have a clear calculation of damage. How shall we express the damage of overfishing? It's hard. We don't have a unit even for that. We potentially dissipate fraction, but even though I have to say, overfishing is not included yet here. So It's not complete. If you recall what I told you, what we can include and what we cannot, if you recall that slide. Direct use of plants. It's not. LCA is still weak in using that. But still, it has the advantage that it can more easily include new items. And it's simple, which I think is an advantage. This is a critical point. Each item that you saw basically is identified as having a weight on its own. And the other one, positive, certainly it has a very broad science-based foundation, which sounds basically good, and I think it is good. You could add economic weighting at the end of these damages. You can calculate, a person year in economic terms is about $100,000 just for production value. And there was a large project of the European Union, external cost of energy, which did that final step in euros. Also the ecological effects and the resource effects. And critical, I mentioned a few times. I would like to give you a few more examples, 2 more examples, to show you why it's useful to have such a method in practice. One, it's a client of mine. It's the analysis of core processes of a restaurant, or, well, I don't know, a food chain that you might know, just for the Swiss operations. And when we started doing the analysis for them, and that's one point, to them, they were not aware that packaging was not their major concern, because all the trouble they had in public was because of the packaging waste. So when we did this quantitative analysis, the result showed that packaging waste shows here, while this is the production of electricity. Now this then led to a change of their internal environmental management, and they started focusing on energy consumption, of the electricity consumption in the restaurants, which produced new programs, etc. So just the fact of having done that analysis once reoriented their environmental management. Of course they have to communicate on packaging and try to improve the packaging and blah blah, of course, but they saw something else. This reminds me of the joke of that person walking home late at night, and he sees another person under the street light looking for something. He asks, you know it? What are you looking for? Well, I lost in Switzerland we have really valuable coins, $5. I lost a $5. Okay, so he also looks around. Where did you lose it? Well, down there at the corner. So why are you searching here? Well, it's way too dark over there. So that method allows to see where it would be useful to search for alternatives. Something that you don't see if you don't have that at hand. Second example, that dates many years back. Another client of ours where my colleague did this basically same analysis. You take the processes of the organization. That doesn't include upstream of the products. It's just their processes, storing and distributing and servicing Gallen, Switzerland. And then they realized, yes, heating is important, and what is this? The service cars of their service engineers driving around all the country. The country is slightly smaller than New Jersey, but still. And so they started developing programs in this field. The cars. Well, what can you do? You can buy more efficient cars and you can train your drivers. And that's what they did. And it developed very nicely. Today, this is even part of standard driving lessons, EcoDrive. And it dates back to that analysis because they started to develop these courses. But then some people there said, well, we should look at the products. And they just started doing first steps, and this is again the same represented, the core balance. And they looked at their products, not at the cameras, but at the time copiers and fax machines. They were still active. And what they realized was that on an annual basis, the electricity consumption of their machines were way more important than their own processes, and the paper even more. So they started looking at alternatives for paper, and they found recycled paper, yes, but some of them don't work. So we have to make sure that our clients get the information which recycled paper works in the copiers. And that one led to two engineers saying, these machines stay idle most of the time. We could develop an electronic device which standby. And then they wrote to Canon Japan and they said, don't touch the products for warranty issues. And they said, yes, but we have this environmental policy and we did the calculations and we see this is really relevant and we should do something about it. And I said, okay, try it. And they did, and today all the machines have standby functionality. And that was one of the sources for that. It would have been found anyway, but we don't know when. And the third is, and you can't find such things if you don't have a single score assessment. This is my experience. I look for the third one, which I would like to show you. Innovation. Innovation is difficult to handle because you don't have all of the data before you do the processes. So innovation with new processes is difficult. Some innovations don't work. Carpooling is but people at the sanitary tube and device producer, Geberit, maybe you know that. I'm not sure if they sell in the US. In Europe, they're quite well known. They had the idea of doing a urinal which was battery driven. I mean, of course you have water, but opening and today you even have waterless, but that was before. They said, some people said, why don't we develop a water-based urinal which doesn't need cabling? First of all, it's a hassle. You have to organize the electrician and the plumber at the same time, which is always a hassle. Second, basically you don't want electricity and water in the same device. They don't fit. So why not doing it with a battery? Because the opening and closing device works just for milliseconds. Flop, flop. And you have a measure which needs to run currently, but this is on low voltage. And they realized, well, one battery would work for 10 years and you wouldn't need cabling, which makes it cheaper. And then the environmental guys said, forget about batteries and environment, come on. That's a trade-off, right? We add a battery, we don't use cables, we say, ooh. And they did the LCA, and interestingly enough, the result was, you have the urinal itself, which is the same. That's the environmental impact of the battery solution, and that's the electricity solution. Well, why? Here we have no details. I've seen the detailed report. Well, most of that is the standby consumption of the transformer for the sensor. The sensor has to run all the time. And if you have a 110 volt, or in our case 220, 230 volt connection, you need a transformer for the 5 volt of the sensor. And that runs 8,000 hours a year. And that's overwhelming everything. So in that case, the LCA helped a new idea which was actually considered critical from an environmental point of view. Because they said, well, the battery shouldn't be. We shouldn't invent a new battery-driven device. And the result was contrary to expectation. That would end the presentation part. And now to whatever you have questions or discussion, we can go into. Hi.
I have two questions actually. First is about energy efficiency. You just had 55 miles per gallon energy efficiency standards put by Obama administration. And even with the implementation of that, the behavioral researchers show that even if you put that, people still want to go further, 10%.
Distance-wise, you mean?
Yes. And how do you come up with a solution for the behavioral difficulties? And how the weighting process, the second question is how you analyze the annual rainfall, for instance.
Annual rainfall.
For the water weighting. Because
Okay.
droughts happen.
Okay, these are two questions. First of all, my share of all this is much more humble than what you underlyingly expect with your question. Rainfall would lead into water shortage or not water offering. What's the situation? Angebot? Supply. We can only use statistics which were done by other people, and then yes, of course, rainfall is a key element of water supply. Very rarely, like in Egypt, you have water coming in a river, but usually it's rainfall. So in such calculations, yes, we would use such statistics. I wouldn't do any rainfall statistics myself. Does that answer the second part of your question?
Yeah. Yeah.
The first one, the behavioral part. First of all, I think this is a key aspect of environmental economics and understanding. So I'm supportive of the topic very much. I don't think it has a relation to the method of assessment of environmental impacts. I also don't think you understand it like this. Or then you mean the development, whether development aspects are included in calculations of weighting methods. Yeah. Like perspective. We haven't done that. Let me just find a slide which gives a frame to answer on. If I go back to this, which is one approach, but what we have in common in all is unseen process tables with a lot of assumptions, how much you need, when did they happen, what technology was used. So there is a lot unseen here, which happens first. Then we have emission values, and we have some abracadabra to do a weighting method. What you are asking plays here. If we have different regulations, what will it change in the behavior of the transportation processes, which are also here, which then lead to CO2 or NOx and others and land use. So that happens here, and it's totally independent of what happens here. Independent in the sense that such a method gets developed and published, and then it will get renewed after a few years. But these processes happen on a current basis, and each time you do an analysis, you will again ask yourself, well, which process data shall I use? 55? And how many miles? So it's not in the same moment that you ask this. But we could think of doing perspective analysis of this and say, well, let's think of the city of the future. How will New York or Cleveland be in 2035? or 2037 in 20 years, and think of a master plan of the city and of construction of roads and and so on, and model the environmental impact of the city then. And then ask, well, what about this? Shouldn't this be recalculated for a expected future scenario? Am I with you?
Yeah.
Okay. And then I say, very interesting, hasn't been done till now.
So this model is not dynamic.
That's correct.
And it hasn't been done by anybody that we're aware of? This kind of modeling of...
That's correct.
Really?
Yes. And
I mean, it's... how computationally intense, like how many variables...
it's not a computer issue.
Yeah.
It's a data issue. Here we would have to think of all the probable changes of human health and environmental system impact changes that will happen in 20 years. So it's a lot of technical, medical, and natural science modeling that would be necessary to do, including political changes. I mean, if Mr. Trump will have 8 years, or whether he will step back in 2 years and there will be re-elections and the Democrat again will change how Cleveland will look like in 2035. I think we would agree on that. We don't know yet how much, but it will. So we would have to do some scenario analysis of possible developments. So it's a lot of knowledge. It's not so much that the data is overwhelming, but that we would have to make sure that we get to some data.
Is it tractable to make scenario analysis?
Is it?
Is it tractable?
Tractable?
Yeah, is it possible to do like different scenario analysis, like create all these different parameters and say what if this happens? Do kind of like tree modeling like they do in financial pricing, where they do all the scenarios and then they find
Yes.
like an average
Yes.
price. Would that be tractable with such model?
I have no idea. I'm not the big data guy, so I don't have much experience in that, and I wouldn't know what you need. Basically, I'm a positive people. Of course, it's possible, but I wouldn't right now over lunch. I wouldn't yet know how. But yes, would be fun. First, I would like to think, well, what for? In what situations would it help? From a scientific point, it would just be fun to do. From a practical point, I would ask, well, where would I use it? For what would I use it? This would probably help define which criteria we would have to look at to do the modeling. Interesting question, yeah? Let me just add to the behavioral part, because this is something one of the most striking things I learned, and maybe you know it. And if you would know it, then I would be very glad, because it would show learning in society. What limits the car use behavior of people?
Oil prices.
Sorry?
Oil prices.
Congestion in traffic.
City density.
Well,
Employment.
sorry?
Employment.
Employment. Well, you mean financial means, or
Yeah, how far your commute is for work. something
okay?
like that.
Okay.
So like where I'm from, Michigan, we have to have cars.
Yeah,
There's-
public transit options.
Yeah, public transportation is.
Okay. A dear friend of mine, second blackout. Turn off the camera. The name will come back. He's a professor at Vienna, Technical University of Vienna. He has, together with a biologist, he has analyzed behavior of bees, and he has compared it with the behavior of men and women regarding movements. Knoflauchel, Helmut Knoflauchel. Unfortunately, he hasn't published a lot.
Gallen.
Sorry?
Gallen.
Ah. So what he realized is that speed limits the behavior. Actually, time. We don't travel a distance, we travel a time. And he compared 3 cities: Perth, Australia, which is similar, I guess, to Cleveland or where you are in Michigan, an Italian town, and an Austrian city. And what he realized was that everywhere, average commuting time is an hour per day, independent of availability of means, of density, of anything. Average commuting time is an hour. And that's valid on average. Some people commute for 2 hours. Some people work at home. Average is an hour. And if you change anything, that will not change. So whatever you do, you may, for example, if you speed up the transport system, you will create people commuting farther. You don't gain time if you speed up the system, you gain distance. Because the time, he says it's a biological, it's not a variable. And why? Because that biologist of his, he did a study with bees. And what did he do? You know, I learned already in primary school that bees have a dance to indicate where to get pollen. And they have 2 dances. Anybody has the same information? I'm not a biologist, I learned that in primary school. Both indicating direction, but one indicating it's close and one indicating it's far. And what they did was they would put to the beehive a little tunnel, which was so small that the bee had to walk. Walk they can, but it's certainly uncomfortable for them. They prefer to fly. So the fact that they had to walk these few meters would change their perception of distance, and the field which was close before became far. So it's effort, right? And our effort is very much defined by time. Of course, money is also an aspect, but we realize that a hike in prices of gasoline does not change that much. It's not the key effort that we perceive. So, for example, Knoflacher proposed to have parking houses also in residential areas. Why? Because it's, well, in a European or in an area with good public transport, you have a rainy day and you have the alternative: either you take the elevator to your parked car or you leave the house to the public transport station. If you have parking houses in residential homes, you have the choice of either turn right to the bus or left to your car. But anyway, you have to go out through the rain. So it's fairer. Or what we have, how do you say? Not incitement, Anreiz.
Yeah, incentive.
Incentive.
Exactly. The incentive becomes comparable. Or he says you have to slow down individual transport to the speed of public transport. So congestion, yes. Congestion is the only way of curbing traffic. And that's why I didn't plan to show it, but I still have it so close to me that I just couldn't delete it. It looks like this. Right? And we make them everywhere. And we have made them since we introduced cars. That's another topic. So, yes, congestion is actually, probably congestion is the physical result of that biological constant. That we use the car as long as it's easier, and it gets more difficult when we can't advance. Okay, I don't know, that wasn't, it relates to your question.
Yeah,
Well, you showed an image where different biodiversity measures the impacts that we have, like climate, etc., etc.
Hochström, yes.
In connection with
That one?
yeah, in connection with kind of shining the light on what the source of the problem is. You mentioned that not all of them kind of fix climate change, but if you focus more on something specific like rate of biodiversity or other problems, much like in the product system where you look at what's causing the most CO2, is targeting that specific issue. In this case, biodiversity can fix other issues as well, or is it more? Or is the solution more specific, or is the solution is fixing the particular fixing the more general case as well, or what sort of direction?
Yes. I showed this because Hochström compared with an approach which one would have to discuss various environmental topics. Some of them would get represented in the methods I showed you in a similar way. Climate change would be calculated the same way. Acidification would be calculated similarly. Aerosol loadings are not yet quantified. Okay. Nitrogen, similar. This one, no, because this one is already 2 steps further. Because you do something. This is something we pretty much directly produce. The impact on the nitrogen also, but this is the result of quite a few different and distinct. We can do it by chemicals, we can do it by direct physical impacts, and so on. So, coming back to your question, some of those criteria or impact types, be it on that level as Hochström showed it, or be it on the other where I showed you the many stacked comparisons, which do not harmonize, they are not harmonized totally. Some of them run in parallel, and some of them not at all. And in case of trade-offs, well, a larger car and a smaller car, there everything would almost run in parallel. Not totally, because with the catalytic engine, a larger car per kilometer emits roughly the same than a smaller car. NOx, not CO2. CO2 is dependent on consumption. So you have situations where various environmental effects run quite in parallel. You have situations where they do not match at all. In the stacked bar example, you saw that these 2 alternatives don't run in parallel. In half of the cases, red was better. In half of the cases, blue was better, to a varying degree. No, I think my experience is that and that's why I think these weighting methods are necessary, because you can somehow reflect trade-offs. Trade-offs are the expression of the fact that things do not run in parallel. If there wouldn't be trade-offs, then you could say I take one indicator and what's better in that indicator will be better in most. And my experience is no, it's not. Often it's not the case. Does that answer your question?
Yeah. Well, to follow up on that actually, is you mentioned in terms of the bar example, believe you had an example with McDonald's and then targeting electricity use. Could
Yes.
that produce a lot?
That's another bar, yes.
All right. Does fixing that electricity problem help McDonald's profitability as well, or does it take
Profitability?
Yeah. Is fixing that issue, knowing where to look, saying the electricity is the problem, does it also help with their profits as well? Like there's more of an incentive than just reducing carbon.
Okay. That's a totally different question, which I didn't touch upon at all. What is the relation between environmental impacts and economic effects? It doesn't run totally counter. but it certainly doesn't run parallel. In that very aspect, it was, well, very often we see that economic aspects economic side can profit from environmental improvement, but the economic impact is too small so that it would be looked at specifically without an environmental pressure being exerted in addition. So yes, based on this, I mentioned they started a program on energy, and in that I was involved quite in detail, and we realized that same size restaurants would differ in electricity consumption by a factor of 2. Not all of it was manageable, but there was some money in for some of the restaurants. Yes, part of it was possible to be dealt with environmentally and economically to a positive side. And then other things have paybacks which may or may not be in the framework of what the CFO supports. That's then a question of company standard. So yes, partially.
I was wondering, I had a question about the scale of the assessment. So I see you can do individual firms, individual products, you can do industry, global. I'm just wondering like what you mean by it.
When we published that method for the very first time, I added a column which would say, well, what's the environmental relevance of Switzerland in a year? So I had already in mind doing that just to show what, I mean, it's a simple math exercise. As a flow, you just take the flow that you already have as current flow. It's very simple to do. 4 years ago, a colleague of mine did a much more elaborate calculation in the sense that he analyzed Swiss consumption, which is not the same because we are, maybe as in New Jersey, we import more physically than we export. We export more services and we import more products. So from an environmental point of view, we import more than we export. So the footprint outside he would include. And he would come up with the result that food and housing, especially heating, but housing in general and transport, but in that order, were the most relevant consumption areas. Housing and transport not being a surprise, food being actually a surprise. I think that...
The cows cannot produce enough cheese for you guys, right?
The cows can produce enough cheese for us. We export cheese, but we import soy.
What, to feed the cows?
Yes.
The grass up in the... It's well, they can feed off of that.
The grass is reserved for tourists.
I'm sorry, if this is 1103A, do you have any idea where 1103 is?
1103.
It's the same, I think it just depends